So continuing here with number 20, the derivative of both sides with respect to x. The derivative of x, so let me see, I got my train of thought here. So the derivative of this sum is the sum of the derivatives. So the derivative of x is 1 plus the derivative of the sine of y, which is the cosine of y times y prime, equaling the derivative of the product on the right here. The derivative of the product of xy is the first x times the derivative of the second plus the second, which is y, multiplied by the derivative of the first, which is just 1. And then again, notice that we have a y prime term on one side and the other. We're going to gather those terms to the left side. We're going to move the 1 to the right side. Okay? So we're going to subtract 1 from both sides. We're also going to subtract x, y prime from both sides, which leaves us on the left-hand side with the cosine of y times y prime minus x times y prime, equaling on the right, y times 1, which is y, minus 1. Okay, so step 3 of the implicit process says that we're going to factor out that y prime from all the terms that have a y prime in them on the left-hand side. Y prime factoring out of the first term leaves us with a cosine of y. Factoring out a y prime from the second term leaves that minus x. And the right side is still just that lonely y minus 1. So dividing both sides by the cosine of y minus x. And mind you, this is cosine of y minus x like that. Okay, cosine of y minus x. So we're dividing both sides by that to get that lonely, that y prime lonely by itself is what we want. And that's that y minus 1 over cosine of y minus x. And onward to number 27. So number 27, we're actually finding more than just the derivative. Okay, but again, if we, on number 27, we notice we're supposed to find the lines that are tangent and normal to the curve at the given point. Well, we already have the given point, and now we just need the slope. Well, the slope is y prime. So we just have to find our y prime. And how do we find our y prime? Well, we do the same thing we've done over and over and over again. We differentiate both sides with respect to x. And these are actually a little bit easier because, well, I'll show you why in a minute. The derivative of x squared with respect to x is 2x. And the derivative of xy, so we have the derivative of a product, which is the first times the derivative of the second, plus the second, which is y, times the derivative of the first, which is 1, minus, and then the derivative of our y squared, and the derivative of y squared is 2y times y prime. On the right side, we have the derivative of 1 with respect to x, and that's 0. Right. And at this point, we could simplify and solve for the y prime. In fact, I'm hesitating only because I guess we've already done that. So let's just say we could simplify. We could go dot dot dot. We could go y prime equals all this stuff. Dot dot dot. We have all these things, and then we can plug in the x equals 2 and the y equals 3, and we could get a value for y prime. Okay, but let's say we didn't want to do that. Let's say instead of simplifying and solving for y prime, we're just going to plug in our our x equals 2 and our y equals 3 into this equation here. Okay, because y prime is not going to change whether we put the x's and the y's in early or later. Okay, so in other words, we can replace x with 2. Okay, and so anyway, everywhere we see an x, we're going to replace it with a 2. Everywhere we see a y, we're going to replace it with 3. And then we're going to solve for the y prime. Okay, so the 2's go in where there's an x, and the 3's go in where there's a y. And we can simplify this. We have 4 plus 2y prime plus 3 minus 6y prime is equal to 0. So in other words, we want y prime, but only when x is 2 and y is 3. Okay? And so, because that's what we want. We want the slope at that point. And so we can see it's much easier to simplify when we have actually real numbers in here. So we end up getting 7, and then when we combine the 4 and the 3, then what we do here is combine the 2y prime minus the 6y prime, and that gives us minus 4y prime, and that's equal to 0. Okay, so if we add 4y prime to both sides, again, our goal is to find y prime when x is 2 and y is 3. Okay, so we get 7 equals 4 times y prime. When we divide both sides by 4, we get y prime, let's put that in purple, y prime is equal to 7 over 4. Okay, so that was a nice circle. So this guy right here is our slope at the precise moment when x is 2 and y is 3. So we get a specific number when we replace x and y with what they are equal to. Okay, let's see here. So then what we end up with, we have the slope is 7 over 4. We have the point is 2, 3. So therefore, we have the equation y minus y1 equals slope times x minus x1. And that right there, guys, is the solution. Right there. That's the equation of the tangent line. So that's part A. That's the equation of the tangent line when x is 2 and y is 3. Okay? All this stuff right here, all these things that we did, only are, we do all this stuff just to find that guy right there. Just to find the slope of the tangent line when x is 2 and y is 3. Okay? So for part B, we don't really have any work to do other than knowing our algebra and knowing how the normal line and the tangent line are related. Okay, so for part B, let's go ahead and do that. We still have that same point, but the slope for part B, the slope of the normal line, and I should put down here normal, okay, which is perpendicular to the tangent line. If the tangent line has slope 7/4, then the normal line has a slope of negative 4 over 7, because the normal and the tangent are negative reciprocals of one another, and so therefore y minus y1, which is 3, equals negative 4 over 7. Multiply that by x minus 2. Okay, so that right there, guys, is the equation of the normal line to the curve at the point 2, 3. The only calculus involved in that is just to find the slope of the tangent line, which is, again, exactly what we said from the very beginning, what we're finding when we're finding the derivative of a function at a point. That's the beginning of derivatives, the beginning of chapter 3. What is the slope of the line at the point? Or slope of the curve at the point, or the slope of the tangent line at that point? It's going to be a real number. And the slope is the equation, the tangent, the derivative at that point. So hopefully that makes sense, and let's go ahead and look at I'll make a second video for that next problem.